Generative AI creates content predicting the next probable word. Agentic AI uses that same model to reason through problems and autonomously execute multi-step business logic. Legacy NLP handles requests by extracting rigid keywords. Asking to swap blue shoes for size 10 just routes you to a static FAQ. But agentic pathways identify multi-layered intent, bypassing static trees to dynamically trigger order and sizing flows. This architectural shift replaces keyword-triggered routing with dynamic reasoning chains. Direct enterprise value is generated through the secure execution of autonomous business logic. To understand how this works, we have to look at the large language model. The LLM is a powerful pattern matching engine, but it is confined to the static data it was initially trained on. When you force an LLM to answer a specific enterprise question from memory without access to verified external data, statistical probability takes over. The system generates a response that sounds plausible but contains factual hallucinations. Furthermore, language models lack native execution environments. They generate text, but they cannot independently reach into enterprise software to update a record or trigger a state change. The Agentforce architecture was engineered to bridge this gap. It provides the necessary infrastructure to connect non-deterministic language models to deterministic enterprise data. A raw language model requires a specialized infrastructure layer to become a functional and secure enterprise system. The processing capacity of a language model is measured in tokens. A single token is roughly 3/4 of a standard word, and every token processed carries a direct computational cost. This diagram represents a context window, the strict working memory limit for an LLM. In Salesforce, this window is capped at exactly 65,536 tokens. It is impossible to force an entire CRM database or a 50-page technical manual into this restricted processing window at once. Exceeding this boundary results in truncated context limits, dropping critical information, and causing immediate operational errors. To maintain accuracy, the system must isolate only the exact data required to answer a specific user prompt before the interaction begins. This isolation is achieved through retrieval augmented generation, or RAG. This technique allows the architecture to operate safely within the constraints of the context window. Engineering enterprise AI is a problem of resource allocation, maximizing data relevance within a strict mathematical boundary. The first stage of the RAG pipeline is fragmentation. Massive enterprise documents are broken down into manageable data blocks called chunks. We then run these chunks through a process called embedding, converting text into high-dimensional vector arrays that map semantic meaning. Data Cloud takes these newly generated semantic vectors and stores them within a specialized high-speed vector database. When a user types a natural language prompt, the system instantly converts that query into a corresponding mathematical vector coordinate. Instead of looking for exact matching words, the system calculates semantic similarity to pinpoint the closest matching document vectors in the database. Only this retrieved, highly concentrated vector chunk is ultimately forwarded into the LLM's context window. Semantic vectorization transforms unstructured human language into a precise mathematical coordinate system, ensuring accurate data retrieval. Sensitive business data cannot be exposed openly to external LLM processing servers. Every Agentforce interaction is encapsulated by the Einstein Trust Layer, a multi-stage security pipeline. At the first stage, prompt defense actively intercepts and neutralizes malicious injection attacks. In the second stage, PII masking algorithmically strips sensitive entities, replacing them with sanitized placeholders before external routing. The LLM generates its response using only these sanitized tokens. A subsequent grounding check verifies the response is based on retrieved data, preventing hallucinations. In the final pipeline stage, PII demasking restores the authentic alphanumeric values solely for localized delivery to the user interface. This pipeline architecture allows organizations to leverage external intelligence while maintaining zero-trust internal data boundaries. Once facts are grounded and data is secured, the system requires a specialized execution engine to enact changes within the CRM. This is the Atlas Reasoning Engine. It is the core decision-making module, driven by an 8-step cognitive processing sequence distributed across these 5 subcomponents. Processing begins with intent classification. The system analyzes incoming text to determine the specific domain of the user's request. The agent router then dispatches this classified intent to a domain-specific execution unit known as a subagent. Inside the subagent, The planner component dynamically translates the user's goal into a sequential, multi-step system execution plan. The action execution engine then triggers enterprise tools, like Salesforce Flows or external APIs, giving the AI the ability to execute tasks. If an API call fails or times out, the reflection module evaluates the result and initiates a self-correction loop to find an alternative action autonomously. The Atlas engine functions as a proactive, fault-tolerant system administrator, managing enterprise tasks independently. Bringing this all together, this diagram traces the complete Agentforce intelligence loop, mapping an interaction from the initial prompt through to final execution. Data Cloud provides the semantic vector context, while the Atlas engine simultaneously formulates the execution plan. Atlas triggers a database mutation, the result loops back through the trust layer for demasking, and the finalized secure result is delivered to the user. This interlocking intelligence loop transforms abstract AI concepts into a deterministic and verifiable enterprise workflow. The stability of an Agentforce deployment relies on the technical architect's ability to enforce precise system instructions. Architects must rigorously manage token consumption to stay within the hard limits of the context window and prevent system overload. It is also critical to maintain cleanly chunked, highly structured data cloud libraries to ensure flawless vector retrieval during the RAG process. Scalable enterprise systems now require autonomous reasoning platforms built on a foundation of secure vectorized data.